Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. My name is Wan Muhammad Zafar Al-Haikal bin Wan Muhammad Zaidi. So for today, I will present on study about the salinity intrusion in the lower Chao Phraya River in Thailand. This river is actually a critical source of water for Bangkok, surrounding community, agriculture and industry. However, increasing salinity intrusion threaten the water security, especially during dry period. So this presentation will explore the causes, challenges and the potential mitigation strategies. The lower Chao Phraya River experiences two constructing conditions, which is during period of strong river flow, fresh water dominates and pushes salt water towards the sea. But however, during the drought and low flow condition, seawater can move upstream, contaminating the freshwater supplies. This seasonal shift creates significant challenges for water management and resources planning. Next, salinity intrusion can be understood as a battle between the freshwater flowing downstream and seawater pushing inland through the tidal action, where river discharge in high freshwater winds. But when its discharge decreases, tide become more influential, allowing the saltwater to penetrate the further upstream. The location of the conflict zone determines the extent of salinity intrusion. The two main mechanisms are often used to explain the salinity intrusion. The first one is the drought-dependent mechanism, where reduced river discharge allows the saltwater to move inland. And the second one is the drought realization mechanism, where salinity decreases once rainfall and river flow recover. Understanding these processes is essential for predicting the future salinity event. Next, we're gonna look on the one important factor was the urban runoff. Heavy rainfall event in urban area generate a large volume of fresh water that enter the river system. This runoff temporarily diluted the salinity level and helped reduce the saltwater intrusion. The finding highlight the importance of considering urban hydrology alongside the natural river processes. Next, for a better understanding on this dynamic, researchers use the SCHISM hydrodynamic model, or the long term we call it as a semi-implicit cross-scale hydroscience integrated system model. That advanced modeling system simulate the river flow, tidal movement and salinity transport by combining a different environmental factor. The model provide a more realistic representation of how salinity behave throughout the estuary. The first mitigation technique that have been used is the first one, the water hammer technique involve release a short but instant path of fresh water into the river. This surge pushes the saltwater downstream and temporarily restore freshwater condition. Model results show that the method can effectively reduce the salinity for several days, making it a useful emergency response during the critical period. And the second mitigation technique or strategy focuses on utilizing the side flow and urban runoff. Clean freshwater inflow can help dilute salinity and improve the water quality. However, this approach requires careful monitoring because contaminated runoff may introduce the pollutant into the river system. Therefore, water quality management is essential alongside the flow management. In conclusion, addressing the salinity intrusion requires an integrated approach. dynamic reservoir management, better utilization of urban runoff, adaptive governance, and science-based prediction tools must work together. By combining this strategy, Thailand can strengthen the water security and build a resilient against future climates and hydrological tension. And thank you for your attention.